Now we'll have some applications, and by applications we just mean real-world problems. The material that we've been studying applies to the real world, and we'll see several situations where these techniques can be used to get real answers to actual problems in the real world. Now, problems are typically stated in words. Problems in the real world, we're trying to figure something out. We typically have a problem given to us in words, and we need to translate the words into math and then solve the equations. So going from a real world problem in English to a mathematical representation of that problem is an important step. And we have a general approach that works for a wide variety of problems, and here it is. You simply, obviously, read the problem carefully at first, and you assign variables. You use variables to represent the unknown quantities. And it's generally easier if you can use fewer variables. So if you can represent all of the unknowns with one variable, you can do that. And we'll show you how to do that in just a second. Then you take the problem, you take a pertinent idea in the problem, and write that idea as a mathematical equation that you can then solve. So you make an equation from some given information in the problem and then solve it. And then check your work and make sure you found what you're trying to find. Now, this step of assigning variables, that's a critical step. So we're going to practice that just a little bit. Here are some examples of some phrases or sentences written in English, and I'll show you how we can represent the same ideas mathematically with variables. So look at this first one. One number is 6 less than another. So I know that I have two numbers, and I want to use variables to represent them. Now I could just say A is the first number and B is the second, or something like that, but I'm going to show you how this can be done with one number. I'll use the letter N. Any variable could do, but we'll say N is the first number. And we're told that one number is 6 less than another, so I can say N minus 6 is the second number. Now both of these ideas, the one number and the other number, are both represented in terms of one variable, N. The numbers aren't the same. One of them is N and one of them is N minus 6, but I'm only using one variable, the letter N. In the second example, we're told an airplane carries 20 more adults than children, so I'll say C is equal to the number of children, and it carries 20 more adults, so I can write C plus 20 is the number of adults. So the ideas expressed over here are captured over here. And I'm using variables to represent the important information that's given. This next one, a rectangular field is twice as long as it is wide. So it's twice as long as it is wide. And you can even draw a little diagram. Sometimes a picture is very, very helpful. I'll just draw a little rectangle here and make it about twice as long as it is wide. So let's call the width W. I'll write W is equal to the width. The other important thing here is the length. And we could use L for length, but remember it's always easier if you can use fewer variables. So we know it's twice as long, so for the length over here, I'm going to write 2W. And that way this information, that it's twice as long, shows up mathematically in the problem over here. So the length is going to be 2W. So W is the width and 2W is the length. And the last one, Jim drove 3 times as far as Mike. So I'll say M is the distance Mike drove. So I'll just say Mike's distance. And then instead of saying J for Jim's distance, I'm going to say 3M. Because we're told that Jim drove 3 times as far, so I can represent Jim's distance with an M also. It will be 3M because it's 3 times as far. Now, being able to do this, being able to take a written phrase in English and express it with variables, is an important part of solving problems in algebra. And we'll go through some examples.